So this is one of my favorite lights, and it just died. So lights out, clickety clickety, won't do anything. The base is falling apart. And I got these Wi07 wireless modules, and I'm curious, can I make this light, maybe LEDize it, but make it wirelessly controlled in under 5 hours? So that is my limit, and we'll see how quickly I get there. Well, it's 5:43 p.m. and I just made a GitHub for this, and I'm going to go open KiCad and see what I can do. So right here we have an AP1117, which is the voltage regulator that we'll be using, and unfortunately it makes it difficult to actually go do this, because I could route through there or around there or something, but if I want to get these traces around there, it'd be easiest to jump through the chip. So I'm going to go check and see if I can actually go do that. Of course it's not to the data sheet, but we're trying to get this done quick, not right. One of the ways I get my projects done so quickly is by having these racks and racks of parts. Whenever you buy any part from DigiKey, buy 10 or 20 or 100. Then collect them in these packs. I happen to buy these from Jameco, and they're spectacular. Just fill them up with parts, and then you'll have those parts whenever you need them. So in here I have some AP1117s, and they're the 3.3 volt variety, and we'll go probe this thing out. Let's see what happens here. It's 0 ohms across it, so it looks like I know what I'll be doing. It is 7:09, an hour and a half later, and I am waiting at my printer for my design to come out. We're actually surprisingly on target for this. Might happen somehow. Don't think we need it in the box, but we'll see. Well, it looks like it's going to be good enough. I guess we'll see. Loading in the transparency. Getting ready for printing. Go! Goodbye, blank transparency. Soon it will be hello, new circuit board transparency template. Oh yeah. Not great, but good enough. Check back every couple of minutes, rub it a little bit, and see if it's still slimy after you rub everything off. If it stops getting slimy after you rub everything off, that means it's just about done. You only need to leave it in for maybe another minute or so. And it is 8:03 right now. I have, I guess it's 3 hours to go? Yeah, 3.5 hours to go. So, just another minute. Since it's just baking soda, I'd say it's been about another minute. Okay, maybe a little bit less than a minute, but it's just about time. It's not really slimy anymore. Time to get rid of everything. Take this out. Baking soda, just pour it down the drain. Give it a flush with plenty of water. And now we get started with the etching. Oh, before I forget, rinse off your board. That's not good. Some of these look a little overdeveloped. Means that some of the traces might get washed off. Good thing I made 4. And it looks like it was because I used too much baking soda in there when I was cleaning off all of the unexposed board. If you don't want to, you don't have to really rub them this much. I just generally like doing it because it makes the process just a little bit faster to rub. You can see in some places it's starting to shine through. Almost ready. I think there's maybe 1 or 2 places where it hasn't quite etched all the way through. This one's completely etched. I'm just going to take it out, rinse it off with a little bit of paper towel, and throw it in the rinse. One thing stands between us and finished circuit boards. It's that this wrist-on stuff is completely on the outside. Best way I found to get it off, some good old-fashioned acetone. Yeah, buddy. Let's try to get all the water off. Pour the acetone on. Favorite part of the process here. You can see the wrist-on pull right off the board. Because I did overexpose the board, there is a flaw that I can see. It's right there. I don't see any other flaws. I might discover one later, but yeah, I mean, even when you really mess things up with this circuit board printing at home thing, it's surprising how forgiving it is. It is only 8:36 or 8:37, so I'd say we're making pretty good time. We have a circuit board, though there is a flaw. And I still have, what, 3 hours left? Yeah, just a little under. So I'm going to take and squirt out some solder paste here. This is Quick Chip. This is bismuth solder paste. It's some really good stuff. Oh, I squirted out way too much. Whatever, it'll keep for a day or two. And I'm just going to go put it on the board. So now it's around 300. I wait for a moment, and then I'm going to turn it up to 400. Degrees Fahrenheit, that is, not Celsius. Now I'm going to turn it up to 400. You should start to see the parts just begin to melt. Or the paste to begin to melt to the parts. Yeah, that. Board is still hot. I'm going to go see if there are any errors here I need to worry about. Looks like the chip soldered pretty good. That circuit board error is pretty rough. Don't think I'm going to get away with fixing that without some wire. There's a flaw. Gotta go fix that. Just going to correct these. Ooh. Ah. I can use the solder sucker. Great. That did not work. Didn't work at all. To fix this error, I'm just going to take a little tiny piece of wire here, or a lead or something. I'm going to cut it. I'm going to use my soldering iron to go pull it up onto the place where there was a problem. So, a little bit of solder on it. and drop it on in. Just spent about 10 minutes trying to get this. It's not working. So what I'm going to do instead is just take a wire and jump around the area so that I can at least get this thing to work. I really hate errors. Oops. Wire, jump around area. Now I got that little wire on, so I'm just going to go probe a bunch of spots on the board to make sure points that should be connected are connected and points that should not be connected are not connected. There is a bug. It's a solder bridge on the part. Done. Pulled out. Okay. Time to see if this thing programs. So, for this part, all I really do is I open up something that I know is going to work. And in here I have, in my AV Artcraft folder that I did not commit, I have a Wi07. And I tried to write a Minecraft server for this thing, and it's just not a part that you can do that with. Thought it would be, wasn't. Darn. Oh, wrong USB drive. Port, wrong USB port. Okay, programming. That's a good sign. In fact, that's probably the best sign. I can run a tiny ISP term to see what it says. Of course, it's not going to work because I haven't plugged up one of these yet. This is the star of the show today, the Wi07. Sad we haven't seen it until now. All we got to do is plug in the pins on the board, which are labeled, with what they need to be. So, just plugging these things in one at a time. I have to pull up the datasheet here in a second because I forgot which goes where, but we'll figure that out momentarily. Right after attempting to set the clock bits, I could not program the chip anymore. That's because the trace next to the oscillator is broken. Ah, man, really keep making mistakes. I'll have to go back and fix that. I'm almost running out of time. It is only, it's 9:16 and we only got 2 hours left. I'm back. This time I added a little tiny chip resistor. 0 ohm jumper chip resistor. Seems to have done the job. Let's see if it programs. Yes, it is restored. Much to my surprise, this has actually worked out really well. What I'm really doing here is I can telnet in, send something, and the Wi07 gets it, and it's getting it correctly. This part is amazing that I was able to go from nothing to that quickly. It also has that really annoying timeouts, which supposedly can be gotten around, whatever. Point is, now, we need to turn this into some sort of LEDized device that can accept input from this. Let's go downstairs and give that a shot. Because I was in such a hurry, I didn't actually put any MOSFETs on this board, so there was no way for me to control the lights. What a fool am I. Conveniently, we can just solder those onto something else right now. Let's go. Because LEDs are current mode, and we're going to be hooking this up to a 12-volt supply, gonna have to make sure that it's not going to be too bright. So, let's see here. Have this hooked up. Ooh, that's not good. Let's see if I give it some more current. Right now, I'm only giving it 10 volts, and it's sucking up, or 12 volts, and it's sucking up down half an amp. That's going to be too much. In fact, it's already gotten warm. So 5 ohms is too small. I hope I have something that'll fit. Apparently, all I had to do was just look around, and sure enough, I got this boatload of resistors here. They look like they're probably wrong. Oh. They're all 1 ohm. That's just useless. Okay. If I don't have the right resistors, maybe I can get something a little closer to what I need by putting even more in series. So I'm going to go hook each one, the positive of one up to the negative of the other, on down the chain. That would mean we're going back to just having one light. If this works out, great. If not, we're going to have to go find another way. I guess engineering is just a test in futility, especially if you're trying to get it done without having to go out and get any parts. Okay, let's see what voltage these things like operating at. I just realized I wired this up backwards. Alright, let's try that again. Maybe it'll work this time. Ah, gorgeous. That's 11.9 volts. Get a little bit more current. They get brighter. A little less. Okay, we might actually have a winner here. That's 12 volts. It's really finicky, but it's reasonably bright, and it's at just under 100 milliamps. So that's probably going to be a good fit. Let's go see what our power supplies deliver. Okay. This extra power supply here, it's from like a monitor or something. Not really sure. Don't care. Just gonna crip off the edges. Ooh, we might be in business here. Let's go plug this thing in and see what happens. So use some alligator clips here. Look at current on my meter here, 200 milliamps, and measure it across from here to here. It says 86 milliamps when everything is running. So I'd say that's pretty bright. Looks like it might be a winner. Okay, let's see if we can fit this all together inside of the top of that light there. One of the nice things about this light is that the base is really heavy, and I don't really want to give that up. Let's take a look and see what's inside. It may behoove me to just keep the transformer where it is and clip these wires here and just use the transformer as a weight, as it looks like there'd still be plenty of room for my little thing and the Wi-Fi module in here. Okay, I lied, not plenty of room, but there might be enough. Let's see if that would work out. Curious what was the problem here. Let's see if it was the light bulb. Yeah, it's an open circuit. Oh well. I should have used the stupid wires that already came with it. Looks like it's working pretty good here. Just gotta hook it up to the Ethernet, or sorry, Wi-Fi chip, whatever dongle thingy. Got just under an hour, just over an hour left. I foolishly cut off the switch. I think I'd like to maintain the switch, that if something gets jinky, I can just turn it off and then all power will be cut to the unit. I'm going to just resolder these and then go from there. Then, these two wires, when the switch is on, should have 12 volts across them. You can get these wonderful DC to DC modules off of eBay. They're really cheap. They're down like the $3 range. And they are switch mode. So what I can do is I can hook this up here and this up here, and it is getting 12 volts. Let's see what the voltage on the output is. It's roughly 10 volts. That's a little high. I'm going to drop this a little bit. Let's see, 10 volts. Let's see, just adjust the pot here. Ooh, wrong way. Because we have an AP1117 on our board, we can accept a fairly wide voltage range. So, right there, roughly 4.8, 4.9, that looks good. I have an idea how I want everything. I'm just going to mount it to the sides of this transformer. So, just going to goop the whole thing up in tape here. And I'm going to start sticking our parts to the side of it. So I found 3 points on the circuit board that I could make into separate circuits. Actually, let me just verify they're still separate. I may have messed up. Oh, still separate. 3 points. And I'm going to use those instead of trying to put this MOSFET in free air. Let's plug this up and see what happens. Could have messed wired something. Oh, that's not good. The light immediately turned on. Let's probe around and see why. My attempt to jury-rig this little chip on here, this little MOSFET, has failed. Apparently I've somehow shorted the source and drain. So that means I'm going to have to take the whole thing back off and try to figure out what is going on. Let's see if they're still shorted. Uh-oh. This is not good. Signs do not bode well for our hero. Running out of time. Okay, Huh. Okay, let's hook some power back up to this thing. Yay, the light didn't turn on. Means we might be in business. Let's see if there's voltage on the processor. Uh-oh, 2.7 volts. That's not right. That little step-down driver's not outputting enough voltage. .08 volts. Okay, got a nice solid 3.30. That's good. So, little wireless chip's getting warm. Looks like we're cooking with gas. 10:57, so got just under a little over half an hour left. Now, gonna have to chop this off and hook it up to the power supply. Just soldered this on. Time to use some electrical tape to make it safe. Should probably make sure this thing still provides us the right voltage. .19 volts. Okay. Let's not forget to put the little resistors in. Oops, I actually did forget. Add that before it's too late. The MOSFET connector, that little brown thing right there, is hooked up right there, which I've labeled on the circuit board as PD7 and OC0A. Let's go look at the data sheet and see how we can write some code to make that pin turn on and off according to the incoming Ethernet packet. So the code I just wrote sets up timer 0 to be a PWM controller for OCR0A. I set up OCR0A to be an output. Now I have a loop that's going to hopefully increase over time in brightness and make it brighter. I have yet to actually plug this in, so I like doing things on the edge. Let's see what happens. Okay, it is on, but nothing is happening. Let's first of all see if we're getting any voltage on that pin. Let's go mount the camera back. No voltage. That means that there's something wrong with the code. Let's try turning the pin on and off wildly and see what happens then. Nothing. Oh, I forgot to run it with a terminal. Look at that. Light is now flashing. Okay, back to the computer. Now let's try using the PWM. Looks like that's working mighty fine. Now, what we'll want to do is to change the brightness based on an incoming packet. Let's make it so that the first default is always to turn the light to full brightness. That's what happened. That little tilde sign was not there just a moment ago. What happened was the bit flags were all wrong for this port, and so everything was breaking. I only have 6 minutes left. I don't know if this is going to happen. Let's find out. Alright, so Now I have gotten it so I can control OCR0A. Let's make it so that the very first byte in the packet will always control OCR0A. So, I'm going to say if data len is less than 1, return. But if it's not less than 1, I'm just going to receive a byte here. So make sure you don't have to do anything else funny to say we're done. Nope, we're good. Okay. I'm going to say OCR0A equals read byte. Let's program this on. Actually, let's also remove printf. Looks like I didn't quite make it. It is 11:30 right now. Oh, don't even have the screw in. I don't know. Maybe that qualifies as a success. There's my desk lamp. Hooked up to this power supply. I can plug it in. Turn it on. I can then tell it to turn on or off by the network. Not in the nick of time. Well, oh, whatever. I guess I'll spend an extra 5 minutes and turn it into something neat. Well, it's 11:34, so I'm over by a few minutes. But I can totally set the brightness of this. Let me change it around so it's 255 minus. And you can specify a brightness between 0 and 255, and it turns the lights to that brightness. So I specify 0, they turn off. If I specify 1, it's like a little night light, barely on at all. Let's turn this off, the overhead. And then I can go up from there. So specify 10. Oh, 10's pretty bright. Not really lighting anything though, but it's pretty bright. Let's specify 100. Okay, now we have a nice little lamp. And it totally works. And let's try 255, which is the brightest. Okay, that's actually pretty respectable there. I have no idea if this is going to be sufficient, if I use enough thermal stuff or anything else, but I will say, for little simple projects, that Dragon module makes things pretty neat.